Okay, so welcome back, and now we're going to talk about the area of a sector of a circle. So what is a sector of a circle? Well, it's a piece of a circle. So a wedge, right? So if you think about this, the idea of a central angle, that it partitions the arc length, right? It partitions or cuts off a piece of the circumference. Well, you can look at that sector of the circle, that piece of the circle as a whole as a sector. So that's the definition of a sector. Okay? So what about the area of a sector of a circle? So let's say we have a pie, right? We're cutting up the pie, in equal pieces, let's say. Now we want to know the area of one of those pieces of the pie. How do we come up with that? Well, we do know the area of a circle, right? The formula for the area of a circle. Let's start with that. So the area of a circle is what? It's pi r squared. But just like we did with arc length, we're not taking the area of a whole circle. We're taking the area of a portion of the circle, a wedge, a sector of the circle. So it's a fraction of the area of the circle. So guess what? We're going to do the same thing. We're going to take a fraction of the area. So what's the fraction? Well, it's going to be based on the central angle again. So it's going to be a fraction of the angle. And of course, what's the whole pi? What's the whole one revolution of the pi? 2 pi, right? So it's going to be the same thing. In this case, this is going to equal, so if we're looking at the area of a sector, then it's going to be the fraction, right? Theta over 2 pi times pi r squared. So it's a fraction of the area of a circle. So again, notice that things are going to cancel out. We get the pi's cancel out. And what do you end up getting? You end up getting pi over 2 times r squared, or 1/2 theta r squared. And so that's the formula in radians for the sector of a circle. Okay, so again, this is for when theta is measured in radians. Okay, so next we'll do some examples.